Hi everyone. Today is part 2 of factoring x squared plus bx plus c. And when we ended part 1, I was talking about the fact that there is no number in front of the x squared. It's not 2x squared plus 5x plus 7. It's just x squared. And today we're going to look at one possible way. It's not the only way, but one possible way where there could be a number in front of there, and we would be able to deal with that. So, last week, we learned how to do something called factoring out common terms. Earlier this week, we learned how, in part 1, how to factor a quadratic, x squared plus bx plus c. Basically, what you're going to see in today's worksheet is questions where you have to do both. You have to factor out the common term first, then do the other type of factoring. So the good news is we're not learning anything new today. This is one of those days where we take two things you've learned before and we put them together into the same problem. All right, so remember I said we don't know how to factor ax squared plus bx plus c yet. And I did put yet here. We will do this later in the year, but for now I said we don't know with the a yet. We don't know how to do if there's a number in front of the x squared. So what I'm going to say is for now, if you do see a number there, try to factor it out first. Notice like if it's a 3, look and see if that's a common term. If every term can be divided by 3, factor that out first. Then once you're done, you should be able to factor it like we talked about in part 1. So let's take a look. And here is one that does have a 3 in front of it. It's 3x squared plus 15x minus 72. Now, what you do not want to do, this is the common mistake. A lot of people look at this and they go, okay, without even thinking about it, I'm going to take the negative 72 and I'm going to start my factor tree. It could be 1 times negative 72 or negative 1 times 72 or ... We don't want that. That would not work for this question. So if you do that, what you're doing is you're spending a lot of time on something that's not going to work anyways. What you want to do instead, let's get rid of all this. What you want to do instead is immediately notice this 3 here and say that 3 is not supposed to be there. I can't factor this while this 3 is there. So then you look at the other numbers. You go 15. I can do 15 divided by 3. That would be 5. And 72. I can do 72 divided by 3. That would be 24. So all of a sudden you have a common term. That's what I said earlier in the notes. You're going to do 2 problems in 1. So for step 1, I'm going to divide everything by 3. And remember, we are factoring out a common term or doing the distributive property backwards. We're taking the 3 out. So what you end up with, you have that 3 out front, and let's see what's left over inside the parentheses. On the first term, the 3's cancel, and just leave x squared. Then you have the plus. On the middle term, 15 divided by 3 is 5, and we'll leave the x on that one. Then you have the minus. And on the last term, 72 divided by 3 is 24. Now that we've gotten rid of the 3, now we can do the other type of factoring. So this is what I'm going to do. I'm going to kind of put my framework for my answer. The 3 stays there. Don't just get rid of the 3. Leave it there. 3 stays out front. But instead of x squared plus 5x minus 24, I'm going to factor that part like we talked about in part 1. So I'm going to have the 3 out front that I factored out. Then I'm going to have x plus or minus some number and another factor with x plus or minus some number. And to figure out what those numbers are, we are looking for 2 numbers that multiply to negative 24 and add to positive 5. So let's do this. Let's start with the negative 24 and make a factor tree. See, I did not want to make a factor tree with the 72. Now I do with the 24. So let's start with our factor tree. It's the first one I think of is 1 times 24, of course. I always think of a 1 first. But it's a negative number, so it has to be positive times negative. So for my factor tree, I could have a positive 1 times a negative 24, or a negative 1 times a positive 24. Okay, then I think of 2 and 12, but again, you're getting 2 choices for each one. positive 2 times negative 12, or negative 2 times positive 12. Could be 3 and 8. Positive 3 times negative 8, or negative 3 times positive 8. And it could be 4 times 6. Positive 4 times negative 6, or negative 4 times positive 6. And fortunately, that's our last one, because I'm out of space. 5 does not work, and we're back to 6. So remember, if you look back at the one in the middle there, I'm looking for the two that add up to positive 5. So let's see what these add up to. The first pair, 1 plus negative 24 is negative 23. That's not it. And negative 1 plus 24 is positive 23. So it's not either of the first two. 2 plus negative 12 is negative 10. That's not it. Negative 2 plus 12 is positive 10, so neither of those work. 3 plus negative 8 is negative 5. That's very close, but I'm looking for positive 5. That means it's the other one. Negative 3 and positive 8 are positive 5. Now that's the ones I'm looking for, and I can actually stop adding here. If you want, you can keep going. 4 plus negative 6 is negative 2. That's not the one we're looking for. And negative 4 plus 6 is positive 2, also not the one we're looking for. But once you find the one that we are looking for, you can stop. So basically, to finish this question, I want to put a negative 3 after one of my x's. And since that's a positive 8, I want to put a plus 8 after the other one. And there's your final answer. 3 times x minus 3 times x plus 8. And what we've done is we've done our last two questions in a row. We did factoring out common terms first, that was the 3. And then we did factoring a quadratic, or x squared plus bx plus c, where you're looking for the numbers that multiply to negative 24 and add to positive 5 and putting them into your factors.